Welcome to Octahedral School of Advanced Chemistry. Stereoisomerism in octahedral complexes. Octahedral complexes basically shows two types of stereoisomerism. Number one, cis-trans isomerism or geometric isomerism, and number two, optical isomerism. Now come towards cis-trans or geometric isomerism. Basically, there are three square planar portions in octahedral geometry. Second one can be visualized in like that. Similarly, the third portion can be represented as so because of these three square planar portions, octahedral complexes show cis-trans isomerism. Now the first case, when there are monodentate ligands. Number one, in case of two types of monodentate ligands in octahedral complexes, and if the ratio is 2:4, 2Cl, 4 amino ligands. In this complex, 2Cl ligands, similar ligands, are at 90 degrees, so this is a cis complex. In this case, on right hand side, two similar to minority ligands are at 180 degree, so this complex is trans complex. In case of two types of equal number of monodentate ligands, 3-chloro, 3 amino ligands, for example, so this case is known as basically trans complex. In this case, all similar ligands are at cis position 90 degree to each other, so this is known as cis complex. In case of three types of monodentate ligands, 2:2:2, total 5 isomers are possible. Number one, 2-chloro, 2-aqua, 2 amino. In this complex, basically all similar ligands are at cis position. In this case, all similar ligands are 180 degree to each other, so this is the trans complex. And in this case, 2Cl ligands are at trans position, rest of the ligands are cis, but it will be regarded as a trans. In this case, 2 amino group are trans to each other. Once again, this complex is trans complex with respect to the 2 amino ligands. In this complex, H2O molecules, aqua molecule, are at 180 degree. So this complex is again trans complex with respect to aqua molecules. 5 isomers when there are 3 types of monodentate ligands. In case of all different monodentate ligands, there are total 15 possible geometric isomers, but only 3 of them are practically isolated up till now. In this case, no one is simply cis or simply trans, but all complexes have the different orientation of the ligands in them. So do practice for the more understanding. In case of bidentate ligands, number one, in case of 1 bidentate and 4 monodentate, 2 types of ligands, for example, preference goes to the monodentate ligands. On left hand side, the two aqua ligands are 180 degree to each other. So this complex is basically the trans complex. On right hand side, aqua ligands and chloroligand both are at cis position, so this molecule is said to be the cis. Main point is, if one of the monodentate ligand is trans, then the complex is said to be the trans. 2. In case of two same bidentate and two monodentate ligands. This is the simple case, there's only two monodentate ligands. If these two ligands are at 180 degree, then the complex is said to be the trans complex. If the two monodentate ligands are at 90 degree, then the complex is cis. In case of all bidentate ligands, but the donor atom of each ligand must be different. Otherwise, there will be no possibility of the cis-trans isomerism. Here the main point is, if the similar donor atoms are at 90 degree to each other, so the complex is known as cis complex. If similar donor atom have at least one 180 degree bond angle, then complex will be known as trans complex. Now come towards optical isomers in octahedral complexes. There are basically three prerequisites. There must be no plane of symmetry in the molecule. That means molecule cannot be cut off into two identical halves. First make geometric isomers, then try to make optical isomers, because transform has no optical isomer in most of the cases. Number 1. In case of all different monodentate ligands, we know that there are total 15 geometric isomers and each isomer has optical activity. So total stereoisomers are 30 in this case. Here is the way to draw the mirror image of a stereoisomer. In case of three type of monodentate ligands, 2:2:2, we know there are 5 geometric isomers. Only cis form is optically active and it has its mirror image that is drawn like that. One is D form, another is L form. In case of bidentate ligands, case number 1, if one bidentate and two monodentate ligands are there, for example, this is the trans complex, and trans complex has no optical isomer. The complex is cis. Cis has optical isomer in its mirror image. Second case, two bidentate and two different monodentate ligands. This is a simple case. This is a trans case. So once again, no optical isomers. If these ligands are at 90 degree, that is known as cis case. In case of cis, it has its optical isomer, that is its mirror image. Case 3, all bidentate ligands are there. This is a special case. Complex having any type of bidentate ligands, free bidentate ligands show optical activity. Even transform, in this case, the transform also show optical isomerism. Basic reason is having no plane of symmetry in all cases. See the following examples. Even similar donor atoms, it contain optical isomers. Different donor atoms, even then it contain optical isomers. Thanks for watching.